Come back to my YouTube channel. You are still under power machine internal combustion. You are still under brick power. Now I've given a prone brick. Previously we looked at it pro brick. Now we look at prone bricks. If you have given a prone brick, guys, the arm or the lever, what is important most of the time, the arm or the lever is the same as radius. The same as your radius. Take a note that it's a radius. It's the same as the radius. Alright, we've given the drum, as you can see, lining, all of that, spring. Here it's a weight, where is given. The lever, you see this is a lever, guys. It's the same as what? As the radius. Okay, to calculate the power, here is the formula. The torque, here it is. Weight is the torque, the length, all of that. So let us do some questions so that we'll understand the example. During a brick power testing, a prone brick, you see we're dealing with what? With the prone brick. This is a prone brick. Take a note of that. The result we obtain, the mass at the end of the lever. You've seen that at the end of the lever, obvious, we'll have the end of the lever arm, will have the mass. Here is the mass, that one, the weight there. Or here we suppose you have given the weight. There, and then the length of the lever, which is the radius. The lever is called to radius, that 914.4. Our radius is that. The engine speed we're given there. Says calculate power. Brick power, we know is 2 pi nt divided by what? By 60. So we have there 2 pi. Our n is 120, as you can see there. Okay, we don't have t here. We don't have t. How can we calculate t? We know that, guys, t is equals to what? To force multiplied by radius. The radius we said is the same as the lever arm. Always will be like that. Always. So the force, we've given the mass there at the end, but we know the force is mg multiplied by r, whereby it's a lever arm. Torque is that. The mass there that we're given is 47, as you can see, 6. Then multiplied by our gravity there, where it's gravity 9.81 times the lever. Alright, multiply this by the lever, divide that by 1000, you know, right? Or you can raise that to the power of 3. If we would, okay, we have 9. You can write like this, 914.4. To make this to be in millimeter, you divide this by 1000, so that will be where in meter. You convert that. So this is our torque. That is how we'll calculate what? The torque here. So you can put this there if you want to punch it same time. Then our brake power will be equals to 2 pi multiplied by 120 multiplied by the torque. Here is the torque is 47.6 times 9.81 times 914.4 over 1000. So therefore, okay, all this we're supposed to divide all of this by 60 either way. Then let us do not forget this 60 here. We have 60. Right. Yeah, but it's not necessarily 60 is supposed to divide there. Okay, I can just divide where the speed here by 60. If I divide by 60, obviously 60 is supposed to divide the speed. If I punch all of this as it is, brake power, what is our brake power will be 5365,646 watt. If you want this in kilowatt, you divide by 1000, will be 5,366 kilowatts. So this is how you go about calculating the brake power when you're given a prone brake. The arm lever is the same as a radius. Alright, so here again we've given this typical question here. Example 2, an engine test is a what prone. We take a note, it's a prone brake. What is important there? The result where power, the brake power is that we've given a brake power, and the torque we are given. A says calculate the speed we want N in rest per minute. So it's nice. We've given brake power, we know is 2 pi nt divided by 60. We want N, we can make N the subject there. If we make N the subject, multiply by 60 would be brake power. Multiply by 60, divide by that, and torque by 2, and what torque. So we can substitute what is the brake power is 656 kilowatts times 10 to the power of 3, multiply by that 60, divided by 2 pi. What is torque? Here is torque 1330. It's what 3,332. Then we'll have N in rest per minute. So punching that, we'll get this simply to be nicely, will become nicely 200 rest per minute, 2000 either way, 2000 rest per minute. That is what we'll have there. So that is what is going on. That's how it goes. This is what it goes, nothing more. This is how it goes. So arm lever, this basic arm lever, it's equal to the radius. What you're supposed to know, arm lever, arm, or it's equal to radius. That is what you're supposed to know. So thank you for watching. May you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video.